Okay, guys, welcome to our class for today. We've talked much on latent heat, so for this class, we're going to consider some calculations on latent heat. Okay, so if you are a new subscriber or you are a new visitor to this channel, you are welcome. This is Normal Math Science Tutors Online, and we are bringing physics direct to your very doorstep. If you have not subscribed, please, what are you waiting for? Subscribe to this channel so that whenever we upload a new video, YouTube will notify you. Alright, so you can also reach us through the number that is showing right on your screen, the WhatsApp number. Okay, so hoping that you have gotten your writing materials ready, we'll be solving some problems now on latent heat. Latent heat. Okay, so please let's go straight to the class for today and look at some calculations on latent heat. Okay, so this is the first problem that we're going to solve today on latent heat. So the first question says, how much heat is required to change 3 kg of ice at 0 degrees to water at the same temperature? Specific latent heat of fusion of ice is 33600 joule per kg. Okay, so for this particular question, you are given the mass of ice, and we know when we discuss latent heat that the ice will be melting at a constant temperature, so temperature does not change. Is that okay? So we had that quantity of heat is equals to mass times latent heat. Okay, so in this particular question, you are given mass to be equals to 3 kg. Temperature of ice theta is equals to 0 degrees, though we don't need it. Then latent heat is given to you to be 33600 joule per kg. So these are what you have been given. So the quantity of heat, you can just substitute the values. So there are 3 multiplied by 33600. Okay, by the time you do that multiplication out, you are going to have 100,800 joule. Okay, so this is your quantity of heat. This is the quantity of heat required. So very simply, this is how to go about this type of problem. Is that okay? So you write the equation, then know the variable that you are giving, substitute your equation, and then your answer will come out readily. Fine. So let's go to another one. Okay, so this is another one. This is another question for us to solve. This one says, calculate the quantity of heat required to melt 2 kg ice at 0 degrees and to raise the temperature to 10 degrees centigrade of water formed. Take specific capacity of water to be equals to 42,000 joule per kg per Kelvin, and specific latent heat of ice to be 33600 joule per kg. Okay, so here you are going to find one, the heat required to melt 2 kg of ice at 0 degree. That will be quantity of heat here is equals to ml. Then 2, you are going to find the heat required to convert the ice from 0 degree to 10 degrees, and that will be quantity of it will be mc theta. So at the end of the day, you are going to have, if this is Q1 and this is Q2, you will now have that the total heat TH will be equals to Q1 plus Q2. Okay, so that will give you ml, mass translated heat, times MC theta. Theta is change in temperature. So having gotten this equation, okay, MA plus, this is plus, not times, please. That is plus, this is plus. Okay, so having gotten this, we can now bring out what we have. You are giving mass of ice to be equal to 2 kg, right? Then you are giving the initial temperature theta 0 to be equals to 0 degrees. Okay, then you are giving the temperature of water form to be, let me just say this is theta 1 to be 10 degrees. So from this now, change the temperature is equals to 10 degrees. 10 minus 0 is 10. Then latent heat of ice is given to you. Right? Then specific latent heat of water is given to you 4200 joule per kg per k. This is joule per kg. Latent heat of ice joule per kg. Okay, so having gotten on this, we can now substitute into this equation, so that total heat is equals to, now you have mass. Okay, you have mass. Then mass is 2. Mass is equals to 2 times specific latent heat plus 2 times specific latent heat of water plus times change in temperature, which is 10. Alright, so having gotten all this, you can now begin to solve to get your final answer. Alright, so by the time you multiply all this together and add up, this will give you 672,000 plus 84,000. Okay, if you add up all this, it will give you the total heat. That is 75600 joule. Okay, so you see how we were able to solve this. You know that the heat required to convert 2 kg ice as to melt it is the quantity of heat to melt this one. This one has to, the melting heat is the latent heat of fusion. So this does not require temperature change, because there won't be a change in temperature while the ice is melting. After the ice has melted, the temperature will begin to increase to 10 degrees. That is where you have change in temperature, and in that instance you use the formula for specific heat capacity, which is MC theta. While for the first instance you use formula for latent heat, which is ML. So by the time you add the two together, it will give you the total energy or the total heat required to convert this 2 kg of ice to 0 degree and to reduce the temperature to 10 degrees centigrade. Okay, so that is how to go about this type of question. Question number 3. This one says that a tap supplies water at 15 degrees centigrade while another supplies water at 90 degrees centigrade. So this is like mixing hot water and cold water. Okay, if a man wishes to bath with water at 30 degrees, calculate the ratio of the mass of cold water to the mass of hot water. This is interesting. Okay, so this one is interesting. What you should know when we talk about heat transfer or heat change by mixture, calculation of heat capacity by mixture, we said that heat loss by hot water say QH, heat loss by hot water. Let me just represent that one by QH so that I'll reduce writing. So if I say heat loss by hot water, heat loss by hot water, right, is equal to heat gain QC by cold water, gain, heat loss, heat gain by cold water. Okay, so this one will give you MC, change in heat, change in temperature for hot water will be equals to MC, change in temperature for the cold water. Okay, so having known this, we can now say that you are giving temperature of cold water, that is if I say change the temperature for cold water is equals to the final temperature of the mixture is 30 degrees. Say temperature final is equals to 30 degrees fine. Okay, initial temperature of cold water is equal to 15 degrees centigrade. Okay, initial temperature of hot water is equals to 90 degrees centigrade. So now what we want to look for first now is change the temperatures. So change the temperature for cold water. Let me say change the temperature for cold water is equals to final temperature, which is 30, minus the initial temperature of cold water. So that's give us 15 degrees centigrade. Then change in temperature for hot water, U hot is equals to 90 degrees, 90 minus what? 30. So this gives us 60 degrees. So having known this, we can substitute into this our equation. So from this equation, we're going to have mass times C times change the temperature of hot water is 60 is equals to mass times change the temperature of cold water. Now they said they calculate the ratio of the mass of cold water to the mass of hot water. You know that this is water, hot water, so the specific capacity is the same, so this one can cancel out. So that we now have M60 mass of hot water mean 15 mass, this is mass of cold water, mass of hot water, because it says you compare the two masses. Now you can actually simplify this, simplify 60 and 15. So if you divide 60 by 15, you will have 4. So this will be M4 is equals to M1 as the case may be. Okay, this is cold, M cold, and this M hot. Can put it like that so that you. So now you are looking for the ratio of what? The mass of cold water to the mass of hot water. Okay, so what you are looking for now is M cold to MH hot water. So M cold to MH will give us the ratio of the mass of cold water to that of hot water will give us 4 all over 1. 4 all over 1. Okay, so from this now we'll see that the ratio of cold water to hot water is 4 ratio 4 to 1, ratio 4 to 1. Okay, so this is how to go about this type of problem, ratio 4 to 1. Okay, so that's how to go about this kind of problem. I hope this one is clear. So we'll still solve another one, other problems. This one says that a waterfall is 1,260 meters high. Calculate the change in temperature of a quantity of water that falls from the top to the bottom of the waterfall, neglecting heat losses to the surrounding. Take G to be 10 meters per second square and heat capacity of water to be equals to 4200 joule per kg per K. Okay, so what you want to take note of is that at the height of 12600 meters high, the water will have a temperature that's equal to its energy at this site. Now potential energy here is equals to mgh, mass times acceleration to gravity times the height. Now as the water falls to the bottom of the waterfall, this energy is converted totally to heat energy. So which means that mgh is equals to the quantity of heat is equal to mc theta. Okay, so what we are looking for is change in temperature. Now from what we are given, we have that height is equals to 1260 meters. Okay, then you also have that G is 10 meters per second squared and heat capacity is 4200 joule per kgk. Okay, so substitute all this information to this equation that we have that mass times 10 times height 1260 is equals to m times 4200 times change in temperature. Now this m can cancel out, and then you are looking for change in temperature, so make change in temperature your subject of formula, so that you have 1260 times 10 is equals to what? 4200. So you can work this out. If you work this out, you are going to have all this one will cancel out, so that your answer will come out to be 3 degrees centigrade. So this will be the change in temperature. So take note that this energy at the height is converted totally to heat energy at the bottom of the waterfall, and that is why the temperature of the water at the waterfall is always higher. The temperature is always increased at the waterfall because the potential energy at the height is converted to heat energy at the bottom of the waterfall. Is that okay? So this is how to go about this kind of problems in case you come across them. All right. Another one. Question number 5. This 1 million joule of heat is required to boil off completely 2 kg of a certain liquid, neglecting heat loss to surrounding. What is the latent heat of vaporization of the liquid? Okay, so from our equation we had that quantity of heat is equals to ml. So what you are looking for is L, which is equals to quantity of heat all over m. So here you have already been given quantity of heat to be 1 million joule. So this divided by 2 based on the question, because the mass is 2. This will just give you your latent heat of vaporization. This one is just direct, so this will give you 500. This will give you 500,000 joule per kg. Okay, So I think this one is just direct. You can also write it in the standard form to give you 5.0 times 10 raised to power 1, 2, 3, 4, 5 joule per kg, as the case may be. Okay, so this is 5.0. All right. So I think that one is also simple, and you can easily relate with that. Okay, then let's do one more. This one says a heating coil rated at 1000 watts is used to boil off 0.5 kg of boiling water. What is the time taken to boil off the water? Specific latent heat of evaporation of water is 2.3 times 10 power 6 joule per kg. Fine. So in this particular case, we said that electrical heat energy is equals to power times time equals to mass times latent heat of vaporization. So time will be equals to what? Mass times latent heat all over power. So in this question, you are giving power rating to be equals to what? To be 1000 watts. Then you are giving mass to be equal to 0.5 kg. You are also giving latent heat of vaporization to be equals to what? 2.3 times 10 raised to power 6 joule per kg. So substitute all this information into this formula. We have that time will be equals to 0.5 times latent heat, which is 2.3 times 10 raised to power 6 all over what? Power, which is 1000. Okay, so by the time you work all this out, you're going to have that your time is equals to 1150 seconds. Punch that out in your calculator. You have 1150 seconds. Is that okay? So this is how to go about most of the problems that you will come across in latent heat. All right. So this is your test understanding the pitch. Please try as much as possible to solve all these problems. They are here to help you deepen your understanding. So please don't shy away from them. Solve them, and then you can call us and tell us any challenge that you have. We are ready to attend to all your all your comments. We are ready to attend to all your requests for assistance and for support. We are ready to support you. All right. So before we leave, please, if this is your first time, tell us that you like what we are doing by giving us a like, giving us a thumbs up, subscribe to this channel, click on the notification bell so that when we upload a new video, YouTube will notify you. Also, give us a call through the WhatsApp number that is showing on your screen. Right. So this is No Man Science Tutors Online, and we appreciate your time. We appreciate you so much. Invite your friends to come and enjoy this physics class that we are dishing out and bringing direct to your very doorstep. So thank you, and we hope to see you in our next class. Thanks.